first quadrant enclosed by the graph of f of x equals square root of cosine x, the graph of g of x equals e to the power of x, and the vertical line x equals pi over 2, as shown in the figure above. Write but do not evaluate an integral expression that gives the area of R.
Okay, to find the area of R, I think I'm going to use the usual highlighter. So we have this bound, and then the other bound, and I can make as many vertical lines as possible and always touch the pink and blue, right? So here's my length. So we're looking for the integral from 0 to pi over 2. And it is top minus the bottom. So top function is which one? F of x or g of x? What was it? G of x minus f of x dx. And ideally, we're supposed to wrap this up. I tend to forget. And then if we want to be even more specific, we can even plug it in. So we have e to the x minus radical cosine of x dx. Again, you can wrap it up. The cool thing about the FRQ part, if you do mention g of x and f of x, that's going to give you a point. And this one's kind of stingy, only 1 point on part A. So it looks like we have a lot of points happening on part B.
The A equals.
Oh, you don't need the A equals. But more the better, like over-explain it. And if you even want to be safe and go, the area is blah, go for it, but that's sufficient. Okay, let's go on to the back. Part B. Actually, let's do part B at the very end. I want to do part C. I don't want to feel overwhelmed at the moment. So on part C, Nathan, let's read.
Region R is the base of the solid whose cross section is perpendicular to the x-axis are semicircles with diameters from the xy plane. Write but do not evaluate the integral expression that gives the volume of the solid.
Okay, so we have our volume. And it was a semicircle, so let's kind of recall. It was pi over 8, side squared, and my side is top minus the bottom. So I'm going to kick out the pi over 8, and then we have the integral from 0 to pi over 2. So we have g of x minus f of x, wrap it up, dx, squared is the key. And as long as you have that piece, this alone is going to give you 3 points, which is pretty awesome. So if you knew pi over 8, that's 1 point. And knowing the formula with the integral with respect to x, because it was perpendicular to the x-axis, that always going to give you 2 points. So I like that one for sure, okay? And then let's do the washer question. That's going to involve a little more of the calculus. And I want to look at the question first, and then let's look at the picture. Okay, Sammy, go ahead and read.
Find the volume of the solid generated when R is revolved around the x-axis.
So revolve around the x-axis. Let's what that looks graphically. If I am revolving around the x-axis, it's going to go around this way. Okay? So if I were to look at this and go around, I'm going to have that radius, this one, and the origin. So I'm going to redraw that in that manner on the back. So here's my washer, the bigger one first. And then I have my smaller one with my center. So let's put in, that's my g of x and f of x. G of x, oh, g of x. That was kind of funky. So we have g of x, and this point is f of x, and this point is 0. So I want to worry about which formula we're looking at. We're actually looking at, we kick out the pi on the outside, and we do the big R minus little r all squared. And that's on your formula chart number, or formula card number 10. So let's write the volume. I'm going to kick out the pi. Then we have the integral from 0 to pi over 2. That's pi over 2. And then, because I'm thinking ahead, I'm going to use a bracket instead of the parentheses. G of x minus 0 all squared minus f of x minus 0 all squared, and bracket it, dx. So let's see why that happened. Isn't that the big radius? So g of x minus 0, we have that. And then, isn't this piece the little radius, right? So we have f of x minus 0. So at this point, all we're going to do is plug things in. So let's plug in our actual value. Now I'm going to do my best to fit everything in. So we had, let's do a little bracket. E to the power of x all squared, because 0 really doesn't matter, minus radical cosine of x all squared, and then bracket it, dx. And then we have to evaluate. Now, for when we evaluate, let's see if we can simplify certain things. This guy right here, we have our volume is pi, keep the integral. I can multiply these two, so that's going to give me e to the power of 2x. Minus, something unique happens here. If I have a square and a radical, what happens? They cancel. So I have cosine of x. And then I'm going to wrap that up and say dx. Now the cosine part is not a problem. What is the integral of cosine? Ooh, I have another negative right here. So sine of x. And then for the e to the 2x, let's use our u substitution on the side. So I'm going to write du is equal to 2x. Did I say du instead of u? Silly. And then we get du is equal to 2 dx. And I don't have 2 dx, so let's kick off the half. Du is dx. And that's going to give me 1/2 integral of e to the u du. And something interesting about e to the u, it is itself. So we have 1/2 of e to the u. Since I know my u is 2x, just plug that in. So all that worked just for that one. So we have pi integral. Actually, we don't need the integral anymore because we've already integrated. We have e to the power of 2x, and then we also have the half. We have our minus, and then we're going to plug in pi over 2 and 0. Okay. Let's plug the things in. The first thing I'm going to plug in is pi over 2. When I plug in pi over 2 right here, that becomes what? Just pi? When I plug in pi over 2 here, that's going to give me minus sine of pi over 2. And then minus, I'm going to open a bracket because I'm thinking ahead. Now when I plug in 0, we have 1 over 2 e to the power of 0 minus sine of 0. What is sine of 0? 0? I should be carrying the pi over. I'll do that at the very end. So that's going to go away. So let's see what's happening here. Leave the pi right out there and wrap it all up. So then we still have our pi. And we have half of e to the pi. What is the value of sine at pi over 2? 1, very good. And then we already have 1/2 because e to the power of 0 is itself, minus 1/2. And for, that should be a parentheses, oops. For free responses, as long as you plugged everything back in and evaluated, but did not simplify, this is where you should stop. If you want to combine the -1 and 1/2 and then you mess up, everything else might be wrong, and you don't want that. So our point system, getting this point right here, that's 1 point. And I hope you're grading yourself. And then after evaluating and leaving it in terms of x, integrated, that's 2 point. And our final, this right here, is 1 point.